This will be the last video of this chapter, so we'll end with states of matter and signs of a chemical change. Hold on, it's not clicking again. Let's see if that works. Okay, so a solid has a definite shape and a definite volume. We got our solid, liquids, gases. We won't talk about plasma. So the first is a solid. Now you'll notice that the particles in a solid are typically neatly arranged. They're packed together. They're tight together. There's not much space between them. They still will wiggle in their little spots, but they are you can't compress them any further. So they have a definite shape. You can't squish a solid into a smaller volume. So it has a definite volume, and you can't uh, really change its shape like you can a liquid where it will flow into different shapes very readily. Obviously, you can bend metals and reshape them, but they don't flow into a new shape. They will hold their shape unless you physically force them to change, if that makes sense. So solids, they will hold their shape and they have a definite volume that can't be changed. A liquid, on the other hand, it does not have a definite shape. It will flow to take whatever shape the container that it is in, but it does have a definite volume. So a liquid is like a solid in the sense that its volume cannot be changed. Uh, and when I say that, not significantly. You can't take a liquid and compress it into a smaller volume. If you have 1 liter of liquid, you can't squish it into a half a liter. It's not possible. Um, so liquid, it's a little bit more disordered. The particles are still close together, but they do flow around each other. That's where you get that flow and that changing of shape, but they're still close together, so you can't force them any closer together. That's why they have a definite volume. A gas, on the other hand, is just complete chaos. The particles are all over the place. They're flying around. There's a lot of space between them. So gases definitely flow. So they will change their shape very quickly on their own. They'll take the shape of the container that they're in, but they will also expand to take the volume of whatever container they're in. Um, so they can expand to fit the container, whereas a liquid will just sit on the bottom of the container. It doesn't take up the whole. If your water bottle is only half full, the water doesn't spread out to take the full volume of your container. It'll only sit on the bottom half of the volume of your container of your water bottle. So gas doesn't have a definite shape or a definite volume, and because there's space between these particles, if you compress a gas, you can get them to squish together into a smaller volume. And then another thing, vapor is another word for the gaseous phase of a substance. So if you ever see the word vapor, it means gas, or it's very similar to the word gas. Okay, now the phase changes. I want you to pause the video and think of as many phase changes as you can. So I'll give you one example. Freezing is a phase change. It's when a liquid turns into a solid. So pause the video, see how many you can come up with here, and then I'll get you the rest of them. So how many can you think of? So the first one I came up with was freezing. Another one is melting. Boiling and vaporization is the third one. Condensation is the fourth one. Now these are the four that you've probably all learned, and you're at least have been taught this once before. The last two, sublimation and deposition, might be new to you. So we'll go over those in a second. So before I go here, I would also recommend see if you can figure out. So we already said freezing. It's going from a liquid to a solid. So see if you can come up with the rest of them. So freezing is a liquid to a solid. Okay, hopefully you paused and got them all. Melting is the opposite of freezing. You're going from a solid to a liquid. So I always like to think of these in terms of water. When water freezes, it goes from a liquid and it freezes to ice, which is a solid. If you take a chunk of ice and melt it, it goes from a solid to a liquid. If you boil water, it goes from a liquid to a gas. And if you think about condensation, if you get out of the shower and your mirror is all fogged up, that's because the gas, the vapors, the water vapors from the hot shower condensed on the cold glass. They turned back to a liquid on the glass, made it look foggy. Again, the last two you probably haven't heard of. Sublimation is a solid directly to a gas. Can you think of any examples? We'll go over an example in class. I have some videos. Or you can Google it if you're absolutely dying to know. And deposition is if you have a gas going straight to a solid. So for these last two, they skip the middle phase. You can go straight from a solid to a gas or a gas to a solid without ever actually going through the liquid phase. They are possible, they do happen. We'll show you some examples in class. And again, this is just a review of what we went over a second ago. Gases are very much disordered. They take the shape of their container. They're very random, high energy. If you cool a gas, it will likely turn into a liquid at some point, or it will turn into a liquid at some point. The particles become closer together. They move slower, but they still have a lot of freedom. That's why they can flow. If you cool them off even more, the particles will slow down even more, and then they start packing themselves together in a nice orderly arrangement, and that would be called a solid, which holds its shape, and it has a fixed volume. Here's another chem joke. A small piece of ice which lived in a test tube fell in love with a Bunsen burner. Said, "Bunsen, my flame, I melt whenever I see you," said the ice. The Bunsen burner replied, pause it if you want to check. Bunsen burner replied, or try to get it, "It's just a phase you're going through." Okay, last little bit here of chapter 1, indications of a chemical reaction. How do you know that a chemical reaction is happening? What are some signs that might indicate to you that a chemical reaction is happening? Again, pause the video, see if you can think of any, but here we go. Number 1, heat is given off. If you mix two things in a test tube and the test tube gets very hot or very cold, it definitely is a chemical reaction happening. If light or sound is given off, that always indicates a chemical reaction. Going back to number 1, obviously if you have a test tube with some liquids in it and it was put in a hot water bath and it comes out and it's hot, not a chemical reaction. It's heated up from the hot plate. But if you mix two things and they quickly get warm without adding any heat, you've definitely got a chemical reaction. Fire would be an example of a chemical reaction that gives off heat. Fire also gives off light. If a gas is produced, if you see it bubbling, now in chemistry, you're going to see a lot of reactions where bubbles are given off. The experienced chemist doesn't say, "Oh, it's bubbling." They say a gas is produced. So try to start using those more advanced terms, I guess. A gas is being produced, not "Mr. Zeta, it's bubbling. Look at my cool test tube, it's bubbling." A gas is produced. So we've got bubbles or a gas being produced right there. You can see the picture. Now a color change. Now this one can be a little tricky. If you mix let's say you try to dissolve a blue powder into water and it turns the water blue. That's just dissolving in water. That's not a chemical change. But if you mix a green solution with a yellow chemical and it turns pink, that's definitely a chemical reaction. You have to have a new substance that gives you that pink color. So that's why this is an okay indicator. Sometimes color changes can be physical, so you have to be a little careful with this one. And then number 5, a precipitate is forming. A precipitate is a solid that forms out of solution. We'll see lots of examples of precipitates in lab. We'll do some demos in class. So here is an example. You got two clear solutions. If you mix them together, you see that you get this cloudy appearance. That is definitely precipitate forming. Okay, so check for understanding. Decide if the following are physical or chemical, or if they're intensive or extensive. We'll do this in class. You can try them now if you would like.